In this video, I will solve for the discontinuity, the x-intercepts, the y-intercepts, the vertical asymptotes, the horizontal asymptotes, and oblique asymptotes for y, or f of x. So let's first factor it. X squared minus x minus 6, that's x minus 3, x plus 2, yeah? And the cubic, we don't really know, so we have to put numbers. So if you put 1, that's not going to work. If we put 2, that's also not going to work. If we put 3, 8, 24, 16, 48. Okay, so if we put 3, no. If we put 3, we will, so x minus 3 is one of the factorings. And then we have this left, and this will be that, because, like, we should just know it. Okay. So, because that's x equals 3, this is x equals 3, and this is x equals 3, we can erase that. And then I'll just erase the squared, and then just write another one here. So this is the function that we have, and for the discontinuity, we should have our discontinuous point should be where the vertical asymptote lies, which is -4. So we have, okay, so let's just first, yeah, because if we put -4 in this function, it just doesn't work. We can't have 0 at the bottom of, I still don't know this numerator. Oh, denominator. Denominator. So we can't have 0 as our denominator, so that part would be discontinuous. So -4, 0 will be discontinuous. Okay? And then the x-intercept. The x-intercept is y equals 0. Okay, no. It's this equals 0. So it is y equals 0, but it's just easier to say it as this because we might actually try to substitute it. Oh, actually it doesn't matter. It is y equals 0. So x-intercept would be x equals -2. So, okay, why did I do this? Alright, I'm just trying to give a little more space because it's too. There's really almost no space to write every single stuff down. Okay. Oh no. Okay, so the x-intercept would be -2, 0. And then when we get the y-intercept, we should think it as x equals 0. So it would be y equals 2 over 4 times 4, which is 16. 2 over 16, which is 1 over 8. Okay, so this is 0, comma 1 over 8. Okay. And then the vertical asymptote. To find the vertical asymptote, we just have to look at what makes okay, for the vertical asymptote, we just have to see what makes the denominator 0. Denominator 0. So if we have x equals -4, we have 0, no, x plus, we have -2 over 0. So that's the vertical asymptote. So our vertical asymptote is x equals 4. X equals -4. And then the horizontal asymptotes would be y. Okay. I would have to explain this as well. So our horizontal asymptotes would be 0 because we can think of it as this. So x goes to we can think of it as x approaches positive infinity and x approaches negative infinity. So actually we don't even have to. Actually, I'll just write it. And if you look at this, and if we just actually solve x plus 4 squared, we have this and this. And I hope you know, if you didn't, you can learn from this video that if the denominator is the highest exponent of the denominator is higher or larger than the highest exponent of the numerator, we get 0. Or more specifically, okay, we can divide the numerator and the denominator by x there and there. Okay. And then, okay, we don't have much space there, so I'll just write here. Okay. Now, if you look at it, when we look at the limit approaches, so x approaches positive infinity, we like to so when x approaches positive infinity, all we have to look at is the x, and actually that should be 0. This should be 0, but I don't know. Yeah, so all we have to look at is the x, the numerator x. So the denominator of this would be 1, and the numerator would be x. So x, this is 1, but what we want to look at is just the x. This doesn't have an x. This doesn't have an x as the numerator. This doesn't have it. This doesn't have it. So we get this. X 1 over x. And then we get this. So this becomes 0. Well, I don't know how to explain I don't know how to because whatever, but this is what I learned and what other people say. So just memorize it. It's just easier that way. Okay. So that's why we get 0. So our horizontal asymptote has to be 0. Y equals 0. And then our oblique asymptotes, we actually don't have an oblique asymptote here because our degree of the numerator is not 1 degree greater than the denominator. So the denominator is 1 degree greater than the numerator, so we can't get the oblique asymptotes. Also, if the numerator, so if it's this case, we will also not be able to get the oblique asymptotes. No oblique asymptotes because the exponent is, so we're only supposed to have one difference of the exponent, and the numerator's exponent has to be greater to have the oblique asymptote. So it has to be, so it should be it should be 1 if we actually had an oblique asymptote, but 4 minus 1 is 3, so that doesn't equal 1. Okay, so we don't have an oblique asymptote here, so we can say does not exist. Okay, thank you for watching the video. I hope this helped. Actually talked about quite a lot of stuff. So if 1 over infinity or whatever over infinity, we get 0. Okay, that's quite important here, and that the oblique asymptote needs the numerator's exponent to be 1 larger than the denominator's exponent. Thank you. I hope this helped, and I'll come back with another video sometime.